Thing like Tesla.
Things like Tesla, Micah here. So here we have our schematic diagram for our badge project. This is part 3. Schematic diagram is great, but now we're going to actually start making this into a physical device. So what we have to do here is for every single component we're going to use here, we have to decide what it's going to be: through hole, surface mount, and we need to get the exact footprints squared away. Then we can hop into the actual board layout process, which should be fun. We'll have to deal with some other physical things, like do we want to have mounting holes on the board? Where do I want it to be able to bolt on like a hat to a Raspberry Pi or to an Arduino? We'll get to that. So we have the schematic here. Basically, as we left it last time, the only change I made was I made these connectors not screw terminals, but just basic connectors. So we are going to go through the footprint editor, which is this guy here. It's the bridge between the schematic diagram and the physical layout. And we have to assign footprints to all of our components. All right, so here it's listing all the components. For the capacitors, I think I'm going to use 0805s for those. I'm not sure what the difference for hand soldering is, but hand soldering sounds good. Decoupling caps. All right, display 1. Might come back to this one. I thought I had the display. I thought I had the footprint all loaded for that, but maybe not. Let me come back to that one. Okay, J1 jumper in. That's just going to be a pin header. It's a 3-pin header. Q1 and Q2 are already signed up here as SOT23s. That's good. Resistor. These are standard resistors, probably 0805s again. Now this notation, 0805, is actually in a weird unit. It's actually in centi-inches. That's right, hundredths of an inch. So it's 8/100ths of an inch on one side and 5/100ths of an inch on the other dimension. There are metric versions of that too, but it's confusing and hardly anyone uses it. All right, resistor networks. I'm not seeing what I want here. It's not SOIC, and it's not DIP, dual inline package. So we'll come back to that in a second too. And then, well, let's look at that right now. So here's the DigiKey page where I ordered these parts from. You can see they're actually quite small. This number here is in millimeters. But we can go to this link, EDA and CAD models. So here's the schematic diagram. Here's the footprint for it. 3D model. Ooh. But what we really want is to download the KiCad format. We'll go through sequential pin ordering, English units, download. So I'm going to import these guys into KiCad, and I will be right back with you. Okay, so that unzips to a file here. It's got some import instructions that seem either out of date or for Windows. So let's try to figure that out in KiCad ourselves. All right, so I can go here to Preferences, Footprint Libraries. We have global libraries and project-specific libraries. This is probably project-specific, so let's see what we can do. On this computer, okay, it doesn't like this directory, but footprint's pretty, it's happy with, so let's see what happens. Footprints, current project only. Okay, did it work? All right, it's thinking about that. Can we do it? Okay. So our resistor networks are associated. Hope this is the one we want. Whoa, that looks crazy. Don't know why there's a swirly on there, but we'll figure that out later. Other than that, it looks basically right. I set up, these are all SOIC 16. All that's left is these 16 segment displays. What I'm going to do, I'm going to try to find one that has the same pinout and footprint, and then I'm going to repeat the same process and get the footprints all set up for these guys. Hang on. Okay, well that was fun. It involved upgrading to a new version of KiCad, redoing a bunch of stuff, but here we are. And when we go to the footprint page, we have footprints defined for everything. Resistor network, 8x isolated, based on the one I downloaded from DigiKey, and footprints for a DIP20. This version of KiCad had a wizard that let me went in and define the exact parameters I needed for that. So we will see how it works. So what we have to do now is create a net list. That's an internal list of all the connections and everything. That lives in its own file. All the wiring details. And then, so we can do a bill of materials. We don't need that. Run PCB new to lay out a printed circuit board. Okay, first thing we have to do here is load in the net list, which I believe is here. Okay, renamed some stuff, that's okay. Okay, that's good. And if the screen looks a little bit differently, it's because I had to turn off dark mode, because this version of KiCad was having a problem with dark mode. But maybe it's having a problem with light mode too. Let me check out and see what's going on here. Okay, well, it turns out if you go to Preferences, Modern Toolset Accelerated instead of Fallback, boom, there's everything. So this is the full rat's nest. It's everything showing lines where things need to be connected up. So what we're going to do is grab onto some of these things. M for move. We can move stuff around. All the connections will follow along with it. And we can figure out what we want our board to look like. Okay, so the pins go this way. So the main thing we need to take into account here is that these displays are laid out properly. They'll be on one side of the board. So it's going to end up being a two-sided board in the end. And these are our shift registers. Let's just move some of the stuff out of the way to give us a little more room. It's a good thing they're numbered. That'll make it easy to sort out later. So I'm just going to record enough of this to give you guys a flavor of what it's like. I really encourage you to dive in and do one of these for your own. Do your own project. See how it goes. What are all of these things? Those are all the resistor networks. Those might be on the big side. We'll see. The game is moving stuff around the way we want it. Get everything nicely set up. We can run traces. We can run VS to switch to the other side of the board. We can flip this whole thing around. I'm going to play with that for a while, and then I will come back and we'll see what it looks like.